Well, hello again everybody. Well, today on the bench we've got this CB radio, and for those playing along at home we've got a Cobra 19GTL. Now I'm sure that some of you will probably remember this radio from a previous episode because it was actually donated to me by our friend and yours, Graham, the radio cruncher. So last Christmas he gave me a big box of various bits of CB stuff because I was starting to get interested in CB, but one of the problems I had is I didn't have any spare parts for anything. So he had a box full of old chassis and stuff like that, and this is one of the things I think he donated to me, really just as a part chassis with the idea of stripping stuff out of it. Now as you can see, somebody's already probably done just that. So we've got all the knobs missing here, it's got the channel select switch missing, it's also got a label on it saying RX good, no transmit, and that's what I thought we could actually have a look at today. I think maybe we did plug it in last time and we did establish that it would receive but it wouldn't transmit. But as I say, it's probably 8 months ago and I've slept since then, so I can't quite remember what state this radio's in. So I think that's the first thing we're going to do with this. We're just going to do some spannering and some testing on her, and yeah, let's see what happens. So just taking a look at the FCC information on the back of it, I can actually see that this is actually an AM radio, and it was designed for the American market. Now AM radios of this type are illegal in the UK, you cannot use them, you should not be transmitting with them on air. Now I can hear some of the keyboard warriors starting to type out already, trying to point out to me that AM is now legal as is SSB. Well, that really doesn't matter, because to use an AM or an SSB radio in the UK it would have to be type approved, and this radio certainly isn't type approved to be used in the UK. So it is illegal, shouldn't be used on the air. Just to make that quite clear. On the other hand, I don't know why anybody would want to use a CB on the air and talk to anybody anyway. So all we're going to do with this radio is we're going to find out what's wrong with it. We're going to be transmitting into a dummy load today. We're not going to be attaching an antenna to it. So let's get the spanners out and find out what the problem is. Well, I guess before we get started, I should probably make another disclaimer. I know absolutely nothing about CB radios. Don't do what I do because I'm an idiot. So I do have to say the very small amount that I do know about CB radio has really just come from watching YouTube channels. So that includes people like, well, of course, our radio cruncher Graham. You've got Def Pom in New Zealand, who used to do an awful lot with CBs, doesn't seem to do as much anymore, but he certainly used to in the past. Also, he's got his own website devoted to CBs with lots of good information on there, so you could go and check out the Def Pom, Scott. The other person that I watch in America, I think it's Mike's Radio Repair, and I think certainly, probably for sets like this, an AM set, I think pretty much everything that Mike shows on his channel in America is really the perfect introduction to CB radio if you're getting into it. And of course, for those of you watching in the UK, you'll all be very familiar with the UK CB radio servicing channel, and that's run by Richard. He produces a whole host of how to do videos, how to align, how to fix, how to tune FM legal sets here in the UK. So Richard really does provide a brilliant resource for people who want to get into CB radio repairs. So what I suggest you do is don't watch my video, actually go and watch somebody who actually knows what they're talking about, which I'm afraid isn't me. Now of course the first thing that we need to do when we get a CB radio, in fact any other piece of equipment for that matter, and that's probably just take the back off and have a good look at it. Well, somebody's already beaten me to it, they've taken the back off and that's lost, so that's long gone. So taking a look inside, I can see that the wax seals on the various tuning toggle coils, these have been broken, so I assume that we've had some fiddling. That might not necessarily be bad, but this radio's had some adjustments on it. I'm just looking for any missing components. Of course, a lot of CB chassis and PCBs, they actually use them in a number of different radio sets, so it's not unusual to find resistor symbols, in fact capacitor symbols, various component symbols, and there's no component. That doesn't necessarily mean that a component has been removed, it just means that they chose not to fit them in this particular model. So I'm just looking for any work that's done. Can't see anything on the top side of the chassis. Let's turn her over and look at the bottom. So really at my first glance I can't see anything obvious. It doesn't look as though this chassis has been hacked around or messed with, so that's always a good sign, because it means that we don't have to spend time trying to reverse other people's bodges, do we? So to me it looks okay. I think the little bit of flux residue and stuff like that on here is probably original. But having said that, even though it's original, it doesn't stop us giving it a bit of a clean, does it? So I think we'll do that first. Okay, well I just had to pop out to the bathroom there because of course everybody knows the best thing to use to actually clean circuit boards or anything that's really dirty or heavily contaminated like this, absolutely the best thing to use is the wife's toothbrush. So I can just see there's actually a bent up component leg here and it's almost shorting across to the other track. Now it isn't shorting out at the moment, but maybe it could become a problem in the future, so I'm just going to switch the soldering iron on and I'm just going to tidy that up, I think, because well, if I don't tidy it up it's going to annoy me. Remove the old solder and don't use a piece of wire as solder because that doesn't work. Okay. Okay, that is looking better. So we're going to need an external speaker, so I'll just plug that in. External speaker. We're going to need a microphone, which I have got plugged in here. So the first thing that I'm actually going to do is, well, first thing I always do with a CB radio, I'm going to plug it into PA, because that's always a good test of the microphone connections, because there's nothing worse than putting a microphone onto a radio and wondering why it isn't transmitting, and only because you find out you've got a badly wired microphone or there's something wrong with your microphone. So let's just put it into PA. So this will test the microphone. It will also test the amplifier, which is absolutely fundamental to an AM set. So I'll put it into PA mode. 1, 2, testing 1, 2, 3. Wallow. There you go for all the Richard fans out there. Okay, so that's tested the microphone, the switching, and that will have also tested the power amplifier, because it's very important for an AM set that the audio amplifier is making power, because the audio amplifier is actually used to provide the modulation to drive the finals. So yeah, that's important. Anyway, that tests all that, so this radio should be good to transmit. Let's put it into CB mode now. Okay, so we can hear a tone there, so our radio is actually receiving something, as because it does say RX good, no transmit. Let's just check what it's receiving, looking at the test set. We're actually feeding in an AM signal modulated to a depth of 30%, which is what the specification states for this radio, and the test tone we're using is 1 kHz. So as you can see, we're actually feeding in quite a high level signal at the moment at 102 dBm, which is kind of roughly about 1.7 microvolts. We could probably feed in a much smaller signal than that, I would have thought, and still hear it. Well, as we can see, the receiver on this radio is relatively sensitive. I can still hear something at about 0.2 of a microvolt, which is roughly minus 120 dBm. I'm not going to bother with cyanide readings or anything at this point, because maybe we'll come back and have a look at that if we do some realignment on it. But it's actually the transmitter we're here to look at today, so let's just put the test set into transmit mode. I guess what we need to do is we want to key the microphone up. And well, there's a distinct lack of RF power, because in theory this power meter should be jumping up, and it's not. And of course, when you put a radio in to transmit, it should actually draw quite a lot more power from the power supply, and it's only drawing approximately 50 or 60 more milliamps. So for whatever reason, we can see it isn't making any power at its output. So at this point I'm going to switch on my spectrum analyzer, because I think I've said in the past I do quite like using a spectrum analyzer. I think it is probably the best radio diagnostic tool that there is. It can save you an awful lot of time. Okay, there's a little bit of setup that we're going to need to do. We're going to be looking at some very low level signals, so it will depend on your spectrum analyzer, but for me I'm going to go into the amplitude, what's everything set to. Okay, we've got a 10 dBm attenuator in circuit which is internal to the spectrum analyzer. I'm just going to go down, I'm going to leave that, but I think I'm also going to turn on the RF preamplifier because we're really going to be looking at some relatively low signals at the moment. So we've just switched on the preamplifier. So we're just going to go into frequency. This spectrum analyzer, it's got a sensor frequency of 750 megahertz. We're not interested in that, we just want to see the frequency that the CB operates at. So what we're going to do is we're just going to set the stop frequency here to 40 megahertz. So from this side of the screen to this side, that represents a span of 40 megahertz. So the centre position here is going to be about 20, and then at 27 is going to be around here somewhere. So connected to the input of the spectrum analyzer, I've got nothing very much more exciting than just a loop of wire. All I'm going to do is I'm going to take my loop of wire and I'm going to drop it on the circuit board. Well, as you can see now, various spurs have appeared on the display of the spectrum analyzer, and this is really why I like using a spectrum analyzer, because it tells me an awful lot about the condition of the radio. It's kind of carrying out a number of tests all at once. So at the moment here you can see that there's this little peak here, and I've got a marker set up on it, and it's around about 10.2, flicking around 10.2 to 10.3. So that's the main crystal in the radio that we're looking at. So that's working, and then we've got another peak here, and basically if I just switch the radio between channel 0 and channel 40, you're going to see that jump around. So that's going to be the local oscillator. So we're still on receive at the moment, but you can see as I'm actually switching between channel 40 and channel 1, we're actually seeing that the local oscillator is actually jumping. And of course we'd expect that. So that actually proves that our local oscillator, and in fact which is being derived from our PLL, so it's good proof that the PLL circuit is working. And of course that's always one of the big issues with CVs, and the particular complication is the operation of that PLL circuit. Now I'm not going to say that the PLL is dead on frequency, not exactly sure, not going to bother working it out, but we can actually see that it's actually doing its job. If we turn the channel control switch very slowly, we'll see it creeping across. And then when we get to channel 40, it jumps back. Now of course previously we did actually have the signal generator set up, and we could hear a tone coming into the radio, so we did know that the receive path works. But I just wanted to demonstrate how useful a spectrum analyzer is, because it will actually examine several parts of your radio circuit all at the same time. So that was the receive path. So let's have a look at the transmit now. So what I've actually done is I've actually reset the spectrum analyzer. So the centre frequency now is going to be around 27 megahertz, because that's where this radio should be transmitting. I've got the radio set to channel 20, so off the top of my head that should be a frequency of about 27.205. Remember that this is on the American channels, not the UK. Okay, so let's key the transmitter, and immediately we do actually see quite a low level signal here, but this is 27.204. It's flicking around a little bit because of the way that the spectrum analyzer works, but really this is actually showing us that this radio is actually generating the carrier waveform. So again, it's proving the PLL is actually working and stuff like that, because we can see the carrier being produced there. So again, we've proved an awful lot of our radio circuitry. We're really without doing any testing or poking around. So what I would tend to do is I've taken my loop antenna here, and I've just squashed it so it's not round anymore. So I've got the loop, and what I'm going to do is I'm just going to move the circuit around here, and I'm going to go to the driver stage. So you can see that we're getting quite a high level there. Can you see we've got a very high spur there? So actually the RF signal is getting to our driver. I'm now going to go to the output transistor, and you see it falls, which it shouldn't do. So actually the signal is higher at the driver stage. I'll just go back to the driver. The signal's actually higher at the driver stage than it is the output transistor stage. So that actually just makes me think that the problem with this radio is it's got a blown final. So much like a car engine needs three things to run, which are spark, fuel and compression, a CB radio needs two things in order to transmit. It needs a carrier, which looks to be in good order because we've actually seen it there. We are producing some carrier. But the other thing that we actually need is some modulation. We need something to modulate the actual carrier wave. So what we need to just check now is we need to check that we are actually getting the modulation drive to the output stage. I suspect we are, because the very first thing that we did, we actually checked that the audio amplifier was working, because the audio amplifier is actually used to produce the modulation in one of these radios. It actually provides the power to the collector of the output transistors in both the driver and the output transistor. So it could be possible that we've got no modulation. So we can of course look for that modulation. We're just using an oscilloscope to do that, so that's what we'll do. Okay, so what I'm going to do next is I'm just going to check the modulation drive, which feeds both the driver stage and the output transistor. So I can just get at that down here. So if I just wallow, wallow, wallow. So these transistors, they are being provided with both the modulating waveform and the carrier into the base, but the transistor, the output transistor, is still not doing its job. So I think from that it's pretty categorically correct that this output transistor is blown. The only thing is I don't have another one in stock to replace it with. Let's see what we can find. Maybe we can put an alternative in just to prove that. Okay, so I've just cleaned up the pads ready to take our transistor. I'm just wondering if we should just install one temporarily, because I've got a transistor on order, or I've got a pack of transistors on order. Unfortunately, these transistors do seem to be somewhat obsolete now. So this is a C2029. It's not a transistor I'm particularly familiar with because I don't work on CBs that frequently. Let me see what we can find to put in its place. Well, for you it is but a moment, but for me it's actually a few days later. Now I'm sure you're all going to join with me in wishing my wife for a quick recovery after she so generously donated one of her kidneys so we could afford these. So I guess we better go ahead and get these suckers popped in. Well, 2 bottles of red wine and 1 power transistor later, I think it's probably about time we have a go at aligning this radio. But I guess before we do that, let's just see if it generates any transmit power whatsoever. 876 milliwatts. Awesome. We've got some alignment points here which I've coloured in because that's pretty, and we've also got some alignment instructions. Now I've been going through these alignment instructions, I've had a look through them, and I would say that they've been somewhat problematic in that I'm finding mistakes in them, and of course when you're trying to understand how to do something you really need clear instructions, and they might even be small mistakes, but they're enough to be confusing. So the first one here, it says that I've got to adjust L19. So I did spend some considerably time looking for L19 on the board here, and interestingly enough not finding it, because of course there is no L19, but if you read the next paragraph next to it, it says adjust L9. So there's our first mistake, adjust L19, second paragraph, adjust L9. So L19 doesn't exist. We've got to use a voltmeter onto test point 1, and we've got to adjust L19 to achieve a reading of 3 volts. So yeah, let's dig in. So we've got a convenient bit of wire there, we'll use that as a ground return for the meter. And where is test point 1? I did find it earlier. Oh, there it is, test point 1. Is that going to go on there? Come on. Test point 1. Test point 1 is reading 3.8 volts at the moment, and we need 3 volts, don't we? So let's adjust L9. Oh, going the wrong way. 3.9. Okay, 3.00. 3.011. Sure, that's good enough. Right, the next adjustment, I'm going to come clean. It says now adjust L3 to obtain a reading of 15.36 megahertz. I have adjusted L3 to death. L3 is this one here, and adjusting L3 makes absolutely no difference whatsoever to the frequency. it changes the amplitude of the waveform, but it doesn't adjust the frequency. So all I've done, because I don't know any better, I've adjusted this core L3. I've adjusted it just to peak it on the oscilloscope, so maybe we should just take a quick look at that. So this little micro Tocco coil L3, it's actually quite hard to get at and find, so I've taken a black marker and I've actually drawn a circle around it. Now previously I went ahead and I've soldered a tab onto the ground plane of the circuit board, which means we can take a scope probe and we can stick it on there, and now all I've got to do is hold the scope probe against the secondary side of L3 and then adjust the other side. So this is somewhat like flying a helicopter. So what do they say? Rubbing your stomach and patting your head or some such nonsense. It feels very much like that. So let me find my trimmer. Now I can see that I can change the amplitude of the waveform, but it has absolutely no effect whatsoever on the frequency of it. So as you can see, we're looking at the secondary of L3 now, and what I can do is I can kind of increase or decrease the amplitude of it, and well, what I can't do is it doesn't affect the frequency at all. Now we're meant to be able to adjust this down from 16 to 15 megahertz. Now I can't do that. I don't know if that's another typo or what. Now this is meant to be a PLL adjustment, but it doesn't appear to be in circuit anywhere close to the PLL. It looks as though it's part of the first IF. So I'm a little bit confused by that, and I'm hoping that maybe somebody who's a bit more familiar with CBs can just give me some help on that and tell me what I'm doing wrong, because I'm sure it's me. I'm probably doing something wrong, something I don't quite understand there. So of course I've got no intentions of showing my ignorance, so we'll edit that bit out and you'll never be any the wiser. So we'll move on swiftly to the transmitter alignment, and hopefully we'll have more success at that. So what do we need? We need to put the radio into channel 19, which I think it already is. Yes, we're in channel 19, and it talks here about using an output power meter connected to the jack of the transmitter of the CB, and it's talking about using a VTVM, a valve tube voltmeter. We're not going to use that because we've got an RF test set, so the RF test set can actually measure the output power directly, and I think that's what we're trying to do. So what we're going to do is we're going to connect the RF test set, we're going to put the radio into transmit mode, and we're now going to tweak L10 and L11. Let's just find them, because we need to, don't we? So L10 and L11, L10 and L11. So let's do that. No, I've lost my twiddling stick. Maybe I shouldn't have drunk quite so much wine. Twiddling stick. Twiddling stick. Where are you? Twiddling stick. Twiddling stick denied. Oh, I've just pulled myself in the eye with my twiddling stick. Let's put the radio into transmit. Here we go. Transmit. There we go. And yes, we have 780 milliwatts, so here goes with core number 10. Oh, it's going up, 2 watts, 2.5 watts, 2.64 watts, 2.8, 2.9. We're going to do 3 watts. 3 watts, 3.02. Okay, just peak the core there. Okay, that's 3.02 watts. Let's just put my finger on the transistor. How warm is it getting? It's still cold. Let's now go to L11. Can we improve that? 3.22. 2.3. Dropping again, so that's peaking about 3.2 watts. So we're not at 4 watts there, are we? Let's look at the next part of adjustment. Let's take the radio out of transmit, let the transistor have a rest. Okay, so our next transmit adjustments are L12 and L15. Let's just find them, which is that one and that one. They look as though they might be a bit waxy. Oh no, that moves. Does everyone move? That one doesn't move, but I don't think my twiddling stick is a good fit. Let's change that. 3.24. Okay, so that's peaking at 3.24 watts, so we didn't get any improvement there. Let's have a go on the next one, which is L15. Okay, we're at 3.82 watts, so that'll do. Okay, 3.84 watts. That'll drop a bit as the transistor warms up. And we're pulling from the power supply, because we weren't drawing anything previously, were we? When we had the Duff power transistor, we were drawing, I think it was about 400 or 500 milliamps. Well, we're drawing 1.2 amps, so yeah, that's what we'd expect, isn't it? So we've got most of the transmit side, I think, set up correctly now. Let's turn the transmitter off. And that drops back down to 0. Okay, so we've just gone ahead and we've adjusted most of the inductors associated with the transmit power. So that was L10, L11, L12 and L15. And we were getting about 3.8 watts out of the radio, which is what it tells us to adjust the power to. We could have got more out of it, but it says here adjust nominally to 3.8 watts, so that's what we've done. So the next adjustment that we've got to do is actually L18. So this is associated with the second harmonic trap. So that's around 50 megahertz. So this is actually a 50 megahertz filter. So the adjustment of this second harmonic trap is one that's much loved by the old rig doctors, because what they would do is they'll connect a power meter to your radio and then they'll adjust L18 to show maximum power, and they'll make themselves look like there's some kind of genius. You know, maybe your radio normally would only transmit 4 watts, they will adjust L18 and magic bingo, you're actually transmitting 5 watts or more, and they make themselves up as though they've done something wonderful. Actually what they've actually done is just turned your radio into a splatter box. The problem with adjusting the second harmonic trap using a power meter is that a power meter just shows the total amount of power that's being transmitted from your radio. The problem is it doesn't show you where you're transmitting that power. So if you have L18, if you have the second harmonic trap incorrectly adjusted, you will be producing power at 27 megahertz, which is useful power. You're actually transmitting that to people that maybe want to hear it. But you'll also be transmitting quite a lot of power at 50 megahertz, and all that's going to do is interfere with other people and be a nuisance. So unfortunately the only way to really adjust this second harmonic trap is maybe you could listen to it on another radio, a scanner tuned to 50 megahertz. Maybe you could adjust it for that way, but the easy way to do it, and the way you should do it, is to use a spectrum analyzer. And of course they're somewhat rarer beasts, or they certainly were back in the day. Luckily enough we do have a spectrum analyzer, so let's have a look at the second harmonic output from our transmitter. So as you can see, there's a spectrum analyzer. Let's just key the radio up. Now you can see on the left there's a very large signal, so that's our 27 megahertz signal, and it's kind of bouncing up and down slightly because it's being modulated by my voice as I'm speaking. Now there's a much smaller signal on the right hand side, and that's actually the second harmonic, so that's unwanted. But what that's showing you is not only is this transmitter transmitting power on the 27 megahertz band, that's useful power, that's what we want, that's what other people are going to hear you on. We're also transmitting at 54 megahertz. Now that's completely useless. All that's doing is maybe interfering with somebody else's radio. So you can also see that I've actually got 2 markers set up on those signals, and they're what they call delta markers. So what we're actually displaying is the difference between the 2 markers. So we can actually see that there's a difference of around, it's bouncing up and down a little bit, but it's around 49 dB. There's 49 dB of difference between the carrier and the harmonic. Well, that's actually no good. That's very poor. That what you need is any second harmonics, or in fact any spurious signal, it should be at least 60 dBs down on the carrier. It should be at least 60 dBc as they call it, and that's dBs down on the carrier. We're not getting that, so what we really need to do is adjust this 50 megahertz trap, because we should be able to get rid of that little signal there on the right hand side. Well, much to the disappointment of my twiddling stick here that really did want to get intimate with the core, unfortunately the core is not to be found. It's gone. It's been nicked, robbed, it's scarpered. So undoubtedly what's actually happened in the past history of this radio, somebody has done a peak and tune job on it, and what they've done is to actually make the radio appear more powerful than it is, you know, to get a few more units on the power output meter. What they've actually done is remove the core. So rather than keeping the unwanted 50 megahertz from coming out of the antenna socket, they've removed the core, they've defeated this 50 megahertz harmonic filter. So all that useless power is now being pumped out. Now the watt meter can't tell the difference between useful power and the 50 megahertz power, it'll just display it. So probably whoever was doing the tweaking probably thought they were doing a really great job at increasing the transmit power by removing this core, but they haven't. All they've done is made this radio into a splatter box. And I can actually prove that. Now unfortunately I've just had a look in the junk box and I haven't got a core to put back here, but what I'll show you is something called a gimmick stick, and we can just prove it. Well, in the radio trade, this is actually something they call a gimmick stick. So what it's actually got, it's got a piece of ferrite material at one end. Now at the other end of it, we should actually have a piece of brass. So what you actually do is you can dip these into an inductor core. You can dip them in. Now if you dip the ferrite end in, it actually increases the inductance of the core. And if you, so that, you know, that's like screwing the inductor down. Now if you dip the other end in, which should have a piece of brass on it, which I'm afraid this hasn't. If you put the piece of brass in, it reduces the inductance. But what you can do is you can use it to tell if a core needs adjustment, because what you do is you dip the ferrite core into it and you see if the reading peaks, if you like. If it doesn't peak, you then dip the brass end into the core and that reduces the inductance of the core, and if it peaks you know that the core needs adjustment. So these as I say, these are what they call gimmick sticks. So what I'm going to do is I'm actually going to lower the end with the ferrite, piece of ferrite on it. I'm going to lower that into our core, and what we should see is we should see a change in that 50 megahertz trap behaviour. So what I'm going to do is I'm going to take my gimmick stick here and I'm going to lower it into the body of our inductor here, and the deeper it goes in, the more inductive this coil is going to be. And what we'll do, we'll observe the effects on the spectrum analyzer, and I'm hoping that you'll see that this 50 megahertz trap, well, I'm hoping you'll see it'll start working, because when we've got this lowered into the correct point, when we've got this trap precisely tuned, which is what the purpose of this is, we should see that little spurious 50 megahertz signal disappear. So let's have a go at that. Okay, you can see our 27 megahertz signal on the left there, and the little signal on the right, that's actually the unwanted signal. That shouldn't be there. So what we're going to do is I'm just going to drop my little piece of ferrite on the end of the rod. We're going to drop it into the body of the inductor, and hopefully we should be able to tune it, and we should see that signal start to disappear. And if I actually go too far, it actually untunes it, so I need to pull it out a little bit, see if we can get rid of that signal completely. Okay, it's around there, isn't it? See, that's pretty much disappeared now. We're about, well, I can hold it steady. So I think we've more or less got it there. We're about 60 dBs down on the carrier. That's really where we kind of want it. You want to set it as low as possible. I'm afraid that's the best I can do, just holding this piece of ferrite in by hand. And unfortunately I can't really improve the situation because I don't have a core to put into this, into the body of this inductor. So I'll just take the piece of ferrite out again, and of course the unwanted signal comes back. So there's your problem. So unfortunately, until we find a suitable ferrite core that will screw into this inductor here, we won't actually be able to make this 50 megahertz trap function properly. And that in some ways is quite a problem, because when we set this radio's output power to 3.8 watts, of course part of that 3.8 watts was this unwanted part of the signal in the 54 megahertz area of the band, and that was just useless power. So really what we would want to do is we'd want to adjust this trap here so we knew it was working properly, and then we could come back and we could tweak up these other two inductors here, and we could actually output a little bit more useful power as opposed to useless power, which is what this radio is outputting at the moment. So for today I think we'll just finish off these transmitter adjustments and we'll look at the receive section next time. So The next thing that we've got to do is we've actually got to set the modulation. So we've got to set the amplitude modulation control. So that is VR6. So we need to feed in the signal from the test set. So I'm actually going to disconnect the microphone that I was using a minute ago, and just using this connector which goes back to my test set that I'm using. I'll screw that into there. And we're doing about 3.8 watts again. I can see here that the modulation depth is 71%. So what we actually need to do is we need to adjust this amplitude modulation control, which is here. So I just need to adjust this up very gradually because we were aiming for about 95%. So let me see if I can do that. It is quite a jumpy control, this. 86, 87, very touchy. Okay, 95.6%. So I think that's as good as I can get it. Let's have a look at that on the oscilloscope, because it's always nice to see that you're not over modulating and it's pretty. Wallow, wallow. So that's quite pretty, isn't it? So you can see the modulation occurring there. Wallow. I've just frozen the display on the oscilloscope, and we can see at no point does the modulation cross towards zero, so we're not getting any of those characteristic boxcars which are really associated with splatter boxes, so I think that's good enough. Well, I'm hoping that our final adjustment today is going to be the easiest, so we've just got to adjust this output power meter here, and according to the instructions we just have to adjust, I think it's VR5, and we need to adjust that so that the needle rests between the 3 and the 4 mark. Okay, I think that's okay. So if I just shout into the microphone, we should see the output power change slightly. Wallow, wallow. Yep, so I think that's okay. Wallow, wallow. Just goes into the red. Now, as I said at the start of this video, I'm really no expert on CB radio, so if you've got any advice, tips or tricks, please leave them in your comments because I'll be glad to read them. But until next time, thanks very much for watching, and until next time, that'll do. Bye bye for now.